Everyone, good morning, good evening. This is Sudhir from SNAC. I'm a solution architect and consultant working in SNAC, and alongside me, I have Rohan Jadhav, who's working as an Elasticsearch engineer, and he have worked on the Otel as well. And today we are going to demonstrate a live demo of the OpenTelemetry with Elasticsearch observability. So what exactly we are going to cover in this demo? We are going to first explain about the what is OpenTelemetry, what all are the components of the OpenTelemetry, what exactly is it, what it does, what all are the benefits of the OpenTelemetry, and what problems it solves. And followed by the demo that we have built up on top of it. We'll explain the overall architecture, the live demo of it from the backend till our front end, like live services, what kind of data we are seeing over there. Before that, we would like to explain a little bit about the observability. Rohan, could you please come back to the first slide? So this is the presentation of the OpenTelemetry demo environment. What it has, basically the Otel SDK working as a gateway. Then we have APM server and the Kibana. So this is the overall flow of the demo, and it demonstrates the end-to-end observability across metrics, traces, and logs. So before moving to any technical or explanation of what exactly we have done, first we would like to elaborate more about what is OpenTelemetry. So OpenTelemetry is an open source observability framework that provide the standardized instrumentation. It has the vendor neutral telemetry data and unified collection of metrics, traces, and logs. What does it mean by standardized instrumentation? So what Otel is does, before Otel, each and every observability tool has their own language to talk to the application. But when Otel introduced, it has a common language which talks all the applications. Otel act as a foundation of modern observability. So Otel basically, so earlier what we have, each and every observability tool has their own agents and lock-in period as well. But OpenTelemetry is a vendor neutral. There is no lock-in period there, so you can easily replace the backend with the other one if you want. So that is the beauty of the OpenTelemetry. What problem, as I said, what problem OpenTelemetry solves? So OpenTelemetry solves by creating one standardized way to collect the telemetry. So it is using the OTLP standard protocol, which used to collect the logs, metrics, and traces. It's a native protocol used by the OpenTelemetry, which is a vendor. There is no vendor lock-in in it, and it collects the metric, traces, and log and push it to the different sources basically. So before Otel, as I explained earlier, each and every observability provider have their own agent. For example, if we talk about the Elasticsearch, has the Elasticsearch agent and Prometheus exporters, Jackets, and all. What does it exactly mean by telemetry? So telemetry is a combination of maybe three things: traces, metrics, and all. We all are aware of it. What is traces? It's just a request flow, user API, and DB. That kind of flow is going on. Then we have metrics. This is a number of numbers over time. So we talk about CPU, memory, latency, and all. So that comes under the metrics. Then we have logs, which tells the discrete events, what exactly happening, what kind of error code, and also that kind of information basically comes under the logs. So Hotel standardize all these things to generate and send to the from source to the destination. Core building blocks of the OpenTelemetry. OpenTelemetry has the SDK, software development kit. Then Otel collector, it is working as an agent, and the forwarder, it is working as a gateway as well. And the backend. If we talk about the traditional observability versus the hotel, what all are the components in it? So in the traditional observability, we have lightweight super programs called beats. Then we have agents to export the logs. Then we have for performance monitoring, we have APM agent, and then we have respective tools and the backend for the visualization and dashboard. Similar way in the OpenTelemetry world, we have Otel, the OTLP protocol, which is the standardized protocol, which standardize how to collect the metrics, traces, and logs, and then push it. Then Otel collector and the backend. Protocols, this is the important part in the open telemetry, as we are talking about the OTLP protocol, which worked on gRPC. It's a Google procedure call, basically. uh, uh, it works on the HTTP 2.0, basically. uh, so it is very fast because it is working on the HTTP 2.0. What it does, it is very lightweight in terms of the payload. It is in it is very secured, because sending the data between the microservices in the form of binaries. And it gives very high performance too, because it is very lightweight. So it is in the binary streaming support default protocol by the OpenTelemetry. What is Otel SDK? So in Otel we have a different SDKs which supports the it is uh, language specific SDK, which collects the metric traces and logs. So for example, if we talk about Java, we have one jar file, or we can do manual instrumentation of the language. Basically, if we have to do language specific instrumentation, for example for Java, then place the jar in the application, which will uh, collect the metric traces and log and send it over HTTP calls. So what it does, it captures the incoming request, DB calls, HTTP, and the errors as well. Now we come to Otel collector. We say the heart of everything, which means this is the core functionality of the Otel. So collector works in two-way. Otel collector works as an agent, and it is works as a gateway too. What does it mean by agent? So we are running it as a standalone service, which receives the telemetry, processes, and forward it to the backend. So Otel collector has three components. One is the receivers, second one is the processor, and third one is the exporter. So receivers, for example, in the receivers we are using OTLP Open Telemetry Protocol, which is receiving the your metrics traces through the SDK, uh, and then it is pushing to the processors. What processor it does, it receives the data in the form of batches, drops fields. If you want to uh, add new fields, attributes, you can do the sampling kind of ETL kind of work that we are doing here. And then exporters, nothing but just exporting the your traces and metrics to the respective targets. This is the nice uh, by the diagram. We are just explaining from our application how the data pushes to our open telemetry pipeline, where receivers OTLP, Jagger, Prometheus, anything, and then it is processing it to processors, and then how it is processing, proceeding further and pushing it to exporters to the target backend, basically. Total collectors. versus it is, as I said, it is work. We can use it as an agent, or we can use it as a gateway. So if we are talking about the agent, it is running near to the application. It is a lightweight. It is very simple. There is no aggregation, and all we are doing here, coming to a gateway where we are collecting the logs from different agents, pushing to central gateway where we are receiving the logs from all the agents. So it is in heavy in processing, because here we are collecting logs from different agents. So it is heavy in work. It is scalable, and we are doing, because collecting logs from different sources, we have to do the aggregation, and then further we are just filtering it and pushing it to the target backend basically. And this is how Otel gateway works. So we have the application, then OTLP protocol, then we are using load balancer over here, because we have to push it to the gateway collector, and then from collector to the backend, as explained earlier. And coming to the demo part, so we have used the OpenTelemetry demo, standard demo, where it is built by OpenTelemetry community. Can you please move on to next slide? So it uh, so that uh, it has the application which is built on microservices, which is built on different languages: C, C++, Java, Go, Ruby, and all. It is a microservices-based application where it has the auto instrumentations, and in some of the places they have done the manual instrumentation as well. So in our demo, what we have done, uh, we have collected the application traces and metrics using the Otel agent, works as a gateway to, and then push it to Elastic APM, and from APM to Elasticsearch. Key features of the setup is, as we have explained earlier, also it's a vendor neutral instrumentation of the OpenTelemetry, multiple backends. So one of the use case in the industry, for example, if I'll give you the example, one industry want to compare two observability tool, for example, Elasticsearch and Prometheus Grafana. Then how they can do it without changing the backend? So what we have to do is, we can collect the metric traces and logs from the application, and we can push it to the two different hotel platform. Here what we are doing, here we are pushing the metrics and traces to two different observability tool: Elasticsearch and Prometheus basically. So that's how you can do a comparison of two observability tools. So that's the beauty of the open telemetry. You don't need to change the backend. It is not tightly coupled with the backend. Then we have a centralized telemetry collection via Otel collector. Then we are collecting logs, metrics, and traces. It is scalable and cloud native architecture too. Use cases that we have, it's a microservices performance monitoring, root cause analysis, latency, and bottleneck detection we have in our use case. Then in our demo basically, error tracking and debugging, capability planning, and optimization tool. So this is what the use cases that we have covered here. We'll explain this later when we will do a live demo. And what was the prerequisites to set it up? Would you, Rohan, would you like to elaborate it and take it to the demo?
Okay, so we have installed the official hotel demo. So for that, we
Mhm.
have installed it on EC2 instance. So we have deployed the Docker and Docker Compose. Then we have cloned the Git repository, official demo repository. Then we have also set up on-premises Elastic Stack, so which consists of Elasticsearch, Kibana, APM server, Fleet server, and that kind of stuff. Okay. So we have put all the ports for this application to run. The OpenTelemetry demo architecture. OpenTelemetry demo is microservice-based application that simulates a real-world distribution system, service-to-service communication, failures and latency. Each service is auto-instrumented using OpenTelemetry SDKs. To simulate this, there is one application which is running in background, which simulates this. When we will see the demo, we will show that also. So this is the architectural diagram. Over here you can see the this is the application which is running in the Docker, which has this different types of microservices running over here. So we have instrumented this with OpenTelemetry SDKs, which is auto instrumented, which gives us the logs, matrices, and traces, which are sent to OpenTelemetry collector. In the receiver section, we are collecting through the OTLP protocol. Then we are sending this OTLP data. So mainly the traces and metrics are sent to Elastic APM, so that we can enable the Elastic Observability tab in Elastic Kibana. So for that purpose, we are sharing these metrics and traces to APM server first, and then we are ingesting into Elasticsearch. For logs, we are directly storing logs into Elasticsearch as a in index, and we can access this all data through the Kibana. This is the basic architecture which we have implemented over here. And if you drill down the architecture, so this is the service, means what are the microservices running. So these are few microservices which are listed over here. Accounting service, which is developed in .NET. So we have used this .NET SDK. So another service is there, add service, which is developed in Java. So for that purpose, we are using this Java SDK. Likewise, there are multiple services which are coded in multiple languages. For those languages, we are using the language specific SDK agent, which is like Python, JavaScript agent, and Go agent. So all these SDKs send this data to our centralized OpenTelemetry collector, which receives this at OTLP protocol. After receiving same, likewise, the architecture which I have explained, the traces and metrics are sent to APM server. APM server say ingest those data into Elasticsearch, so we can enable the APM observability UI, and the logs are directly ingested into Elasticsearch, and we can access this through Kibana. So this is the architecture. So flow and why APM server is needed over here. So we are collecting this application logs with Otel SDKs. Then those traces, metrics, and logs are sent to OpenTelemetry collector. Then the metrics and traces are sent to APM server and Elasticsearch after APM server. So why we are sending likewise? So to enable the observability UI. So when we are going to the demo section, then we can see what is the APM observability section. Okay. So Elastic APM serves as the OTLP receiver, Elastic compatible processor, and Elastic exporter. Thank you. So let's go to our demo. So let's see first. Okay, so first we will see how our Docker Compose YML file is configured. So this is one add service container settings, where we can see we have added over here Otel exporters, which starts the binary file, which is used to export this add service data. As we have seen in slide, it is coded in Java. So we have added the Java JDK okay over here, and we have added the hotel exporter. So we will drill down into this add service container. So as you can see, we have this Docker file which is for add service. So where we can see is the Docker file, and here we can see we are downloading this jar file, java.jar file, through this OpenTelemetry Git repository, which is over here. So this is downloaded, and we can see into Docker container as well. So here we can see the jar file which we have configured in this Docker Compose YML for this add service especially. So this is how auto instrumentation is working. So we have this jar file and we have added the exporters. After that, we will go to the Docker compose, means sorry, hotel configuration. So how we have configured the hotel collector. So this is the hotel OpenTelemetry collector configuration over here. As we have seen in the our PPT. So first section is the receiver. So from where we are receiving the data to this hotel gateway. So here we are using this OTLP protocol. So which uses this gRPC and HTTP. So we are getting all the data through this all the auto instrumented SDKs. So we are receiving those data instrumented over this protocol. After that, we have different types of receivers which we can say. For example, if you want to check the front end whether it is available or not, that kind of stuff we can check the through this. Okay. Then we have Nginx load balancer. For that also we have implemented the uh, settings for that also. Then we have Postgres. We can check the grab the Postgres metrics. So here we have mentioned the what kind of metrics we need to scrap. That kind of stuff we can configure in our receiver section for scrapping this Redis catching data. Then afterwards we can also collect the host metrics through this receiver section. So here we have configured that like we are collecting CPU, memory, disk, file system, network, and that kind of stuff we are capturing over here. Then we are having this. Okay. So we are also collecting the logs.
Pushing it
Okay.
to
Okay. Okay. 1 minute. So this was so here we are capturing all the host matrices and that. So next part is exporters, as we know. So in exporters, we configured where what is the backend where we need to send the data. So for example, here we have configured the Jagger. Jagger is used to store the traces, which is open source. So after that, so second, this exporter is nothing but a Prometheus, which is used to store the matrices. Then we are using this open source to store the logs, which is these three stack elements are open source. That's why we have implemented. This is the by default tech stack which we get with this demo. And after that, what we have specially configured over here to send the metrics and traces, we have configured this Elastic APM server over here, and to send the logs to Elasticsearch directly, we have configured the Elasticsearch connector over exporter over here. Where we have provided the basic username, password, endpoint details, and the certificate used to authenticate. After that, we have the third section, which is like processor. We can add the different processors. Like here, we are adding a service name to our pipeline like Otel production, which we can see in our observability tab also in Kibana. So memory limiter, how many memory should be used by this and that kind of stuff. Settings also we can add a resource detection, then transformation if you need to make some changes and that kind of. This processor section is nothing worse. It's a filter section. Likewise, we use in Elasticsearch Logstash pipeline as a where we use different filters. That's how we are using the different filters over here in processor section. After that, we have this service pipeline, which defines if you are sending the traces. So from where you are going to get the traces. So we are going to receive the traces over OTLP. So this is a receiver point. Then what process filters you are going to apply over there. So these are all the filters that we are going to apply. Then the exporters. Then where you are going to export that data. So likewise, as I have told, OTLP APM means this is the exporter configured for Elasticsearch APM server. As you can see over here, this is the APM server exporter which we have configured. Likewise, this service pipeline is configured. For metrics, we are getting collecting this many metrics from Docker stats and that kind of stuff. Host metric, Nginx metrics, Postgres metrics, Redis, and that kind of stuff. And we are applying some filters over there, and we are exporting that data to our Prometheus, which is a default text stack, which comes with this official demo. And again, we are sending to our Elastic APM server. Okay, and same with our logs. We can see we have these logs we are receiving through OTLP because those are generated by application. Then we are applying these processors, and also we are exporting to Elasticsearch directly, and OpenSearch, which are used to store the logs. Again, what we can see the sorry, we can see the different containers running over here. So as we know that this application is microservice-based application, so we can see. Okay, let me minimize it a bit. So here, okay, here we can see this is the Docker container. This is open source Docker container over here. Likewise, we have this add service Docker container currency, then accounting, shipping, fraud detection, code. These are some services in our application, product catalog, and payment services there, card services there, Slack UI, email, checkout services there. These are the all the Docker containers which are available over here. So let us go to our Otel official application. So this is what application looks like. So we have this e-commerce based application where there are multiple products listed over here. As you can see, these are the products. We can click on products. We can add to cart how many quantities you want to add, and add to cart, and proceed to checkout and that kind of stuff. This is a basic e-commerce application which we get, okay, which we see in customer. Okay, so how this application is tested? So we have this Locust, uh, which is nothing but a request generator, which generates a request for each and every services, and that's how we generate a fake traffic, you can say, for testing purpose. So this is the application which is running in a separate container. This is our application. So let's go to Elastic Kibana. So as we have seen in the diagram, where we have this traces and metrics going into our Elastic APM server. So by default, Elastic use this observability section. Over here, we can see the all the APM data over here. So I have gone to observability section over here, and that in that we can see the service inventory. Okay. So currently we are in a service inventory. If you recall in our OpenTelemetry pipeline. So we were having one processor which defines the service name. So as you can see, the service name which we have defined over here was like production hotel. So that is the same service name which is integrated over in our application. Okay, this is the service name. We are adding a attribute like environment name, which is like open production hotel. So from here, here we can select the environment, which gives us all the services to that environment. Okay, this is the production hotel. So these are basically all the services which are currently running in our application. Okay. So we can see the service map. So what are the requests flowing and how they are flowing. Okay. So this is the load generator, which is nothing but this application look first. Then this is the front end proxy. Then our requests are going to front. This front end proxy, nothing means Nginx. So our requests are going to front end. Then all the like add service which is built in Java. That's why, and other services, recommendation services, and all that kind of stuff. So over here we can see all the service map to our applications. So apart from that, if you go to this, okay, suppose we are going to see this is a basic APM dashboard which we get in Elastic by default. So where we can see the environment, average latency, throughput, and transaction failure rate. So as you can see, we are seeing the failure rate of 2.2% and 4.4% over here for front end and front end proxy. So let us drill down into front end. So this is the basic overview where what is the traffic latency over the period of time. So okay, we can see, okay, like this. What was the throughput? What is the last transaction, and which is the call that is failing? Like post is failing 12%, which is confirming over here, and likewise. Okay, again we can get the errors. What errors actually we are getting, and what are the dependencies on that this front end service. Okay, if we click on this error, then we can see the occurrences when this error occurred, and last time 4 minutes ago this error occurred. So this kind of stuff we can observe over here. So
Rohan,
this
come
is
down to that error basically. Can you come down to that error?
okay.
What else? Come down. Can you please zoom it a little bit? Okay, saying connection error. So some of the endpoints is not configured properly. So that kind of stuff through the APM that we can do, we can drill down to the failure, the dependencies of each services, and why it got failed. So we can easily trace it down what exactly happening in the application. Go on, Rohan.
Okay, so this is how we can instrument our application using our Otel Otel agents. So this is all about Otel, our
all the
Otel.
services all the services traces metrics, each services has the dependencies, service map, and we have the failed a transaction rate which we can show, and for what reason exactly it is failing, and then the average latency too. So we can easily figure it out which in which hop exactly the latency is more. So we can target that one, and we can think of, and we can rectify how we can fix it. So this is the if you go to go up, Rohan, go up here, go up, no, come down, come down, view full traces, click on view full traces, come down, it is not, go back, come down. Okay, so we have all the services and dependencies in this what we call kind of overview, where we can see how much time each function or each service is taking time. Okay, I think that's it. That's it, Rohan, or do you have anything to present?
Okay, that's it from my side. So this is how we can get the which API causing the latency issue. We can get the each and every
Can you
detail for
quickly
the flow.
present the Prometheus also, if you have logged in, you can present
Okay,
that one too.
okay.
So how
So we also have this similarly. We have this as
in the same
we,
metrics and traces to Prometheus and Grafana too, right?
yes, yes, yes.
For the same application, one application, and through to observability, we are monitoring it.
Yes. So this is a basic dashboard. for this. Again, I think these are all spans and read metrics which we have.
Now go to this one APM dashboard. Yeah, come down. We will have that service map to here. This is log information. Go up. Uh, Go to another one. This is the RED metrics, which will tell the span addresses and the failure. So the same that we have shown in the Elasticsearch tool, and this is the service map of the in the Prometheus graph map. So the same that we have shown in the Elasticsearch tool. Yes. Okay, Rohan. Thank you.
Okay, thank you.
Thank you, everyone. So the closing note to our demo is we have presented the OpenTelemetry demo using the Elasticsearch. We have pushed the application traces to the two observability platform, Elasticsearch and the Prometheus. Basically, the front end was Grafana. So what we have explained in the OpenTelemetry is it is the vendor neutral, it's centralized, controlled, and multi-destination support. So that is the overall demo which summarize it. Thank you so much.